Okay, so we're going to do some group theory. We're going to look in particular at these three groups, and each group is integers 0 to 5. So like this one is 6 integers, 0 to 6 and 0 to 9. And each one is added on by addition, modulus of the number of integers. So modulus 10, modulus 7, modulus 6. What we're going to do is see if there's a relationship between the order of the elements. So the elements for any group on addition, modulus n, is A, which signifies in this bracket here, the generator, is 0a, 2a, 3a, all the way up to n minus 1a. So let's go straight into this group here and see if we can find the order of each of the elements. So let's start with 0. Let's see what set that generates. So 0, keep adding on 0, will only generate 0. So the subset here will be 0 and its order is 1. So I'm just going to write 1 here and let's put it in a little square. Okay, let's look at 1. So see what set that generates. So keep adding 1 to itself, modulus 6. So 1 plus 1 is 2, and I keep adding 1, we just keep going through them all till we get to 5, and then 5 plus 1 is 6, but modulus 6 sends us back to 0, and then we add 1, we get back to 1 again. So this one here is a generator of the whole group because it generates all of the original elements. So this one is of order 6. Okay, let's have a look at 2. So 2, let's put the first one in, and then we just keep adding 2. So 2 plus 2 is 4, 4 plus 2 is 6, modulus 6 gives us 0, and then 0 plus 2 sends us back to 2 again. So now we're just going through the cycle again. So this one has order 1, 2, 3 elements, this one has order 3. Okay, let's have a look at element number 3. So put 3 in there first. So keep adding 3. 3 plus 3 is 6, which gives us 0, modulus 6, and then 0 plus 3 sends us back to 3 again. So this one has order 2. There's only 2 elements inside, so that's that one. Now what about 4? Okay, so 4 plus 4 is 8, modulus 6 gives us 2. 2 plus 4 is 6, modulus 6 gives us 0, and then we add 4 onto 0, then we end up back with the original element. So this one we can see is order 3, and then 5, so 5, just keep adding 5 to 5, so 5 plus 5 is 10, modulus 6 gives us 4, 4 plus 5 is 9, modulus 6 gives us 3, 3 plus 5 is 8, modulus 6 gives us 2, 2 plus 5 is 7, modulus 6 gives us 1, and then 1 plus 5 is 6, which ends us back to 0, and then 0 plus 5 back to the original element. So this one here is also a generator of the group, that's of order 6. Okay, so that completes the first set here. So I'm just going to write here now. So order on the bottom, and then the element on the top. So a nice little table, and then we can work from that, see if there's any pattern. So let's just write number 5 in, and then we can take that off. So I'm going to rub this out on the board, just give us a bit more space. So we go 0, 1, 2, 3, 4, 5. Then the order of each element, 0 is 1, 6 is, sorry, 1 is 6, 2 is 3, 3 is 2, 4 is also 3, and 5 is of order 6. So that's that group there. Okay, now let's take that off the board. Okay, we might need some space there a bit later. Okay, now let's have a look at this one here. integers up to from 0 to 6 modulus 7. So same pattern as before. So 0, keep adding 0, that's just going to be the set 0. So I'm going to write this little table here next to this one here so we can see if there's some sort of pattern going on. So this one here is for 6 plus 6, and now I'm going to write this table here, Z7 plus 7, so element, order, and let's just see what occurs there. Okay, so 0, 1, 2, 3, 4, 5, 6. Okay, so 0 as order 1. So that seems to be the same as with this one here. Let's try 1. Just keep adding 1 to 1 and then each one along. So 1, add 1 to that gives us 2. 2 plus 1, 3. So we're going to keep going all the way along the line to 6. And then 6 adding 1 is 7. Modulus 7 gives us 0. Which then takes, add on 1 to that, takes us back to the original element. So this one here has order 7. So there's all 7 elements in there. Okay, so that seems to be some sort of pattern there involving with this one. Let's see what happens now when we generate 2. So 2, keep on adding 2 to itself. So we get 4, then 6. Then after that, 6 plus 2 is 8. Modulus 7 gives us 1. And then again, keep adding 2 to that. 1, 3, 5. 5 plus 2 is 7. Modulus 7 is also 0. Okay, so now 2 generates the whole set as well. So that gives us 7 as well. Okay, let's have a look at 3. So keep adding 3 to itself on each one as we go along. So 3 plus 3 is 6. Okay, 6 plus 3 is 9. Modulus 7 gives us 2. Then add 3 again gives us 5. 5 plus 3 is 8. So 8 modulus 7 gives us 1. 3 again gives us 4. Okay, 4 plus 3 modulus 7 is 0. So what we know is when we get to 0 and we add 3 again, we get back to the original. So this is of order 7. Okay, let's try 4. So I'll run through this modulus 7 addition quickly. So 4 then gives us 1, gives us 5, gives us 2, gives us 6, gives us 3, gives us 0, which then sends us back to the beginning, which gives us 4. So again, we can see here every element of the group is here. So this is also 7. So this group here has got 4 generators so far. So let's go to 5. So okay, so addition modulus 7 as we go through this. 5 gives us 10, which is 3. 3 plus 5 is 8, which gives us back to 1. Then goes to 6, then goes to 11, which is 4, and then goes to 2, and then goes back to 0. Okay, so 5 generates the group. Okay, this is pretty interesting. Every element above 0 is a generator. So let's try 6. So I'm guessing that 6 is going to generate the whole group. Let's see what happens. So 6 plus 6 is 12, which gives 5, and 4, and then 3, and then 2, then 1, and then 0. 0 goes back to 6. So I did that a bit quick, but you can check that for yourself. That will be valid. Okay, now this is not following this pattern here. This one here is giving all of the order of all the elements from 1 to 6 gives 7, which means this group here has got 6 generators. Okay, now let's try the last one. This group here, integers 0 to 9. Okay, so 10 addition modular 10. So let's start with some space over here. So 0, as we know, 0 will always generate only 0. So actually let's move this across. We need to do our little table here, don't we? So element, order, okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's make that a little bit neater. Okay, so 0 is of order 1. So that does follow the pattern in all of the addition sets. So let's try 1. So if you keep adding 1 to 1, we know from the others you get from 1, 2, 3, 4, 5, 6, 7, 8, 9 all the way back to 0. So 1 is going to be of order 10. So what we can say is that this group equals this. So the integers 0 to 9, so that will equal the whole group. So that's then of order 10. Let's try 2. So keep adding 2, see what set we get. So 2 plus 2 is 4, 6, 8. When we add 8 to 2, we get 0 in modulus 10. So then the order of this little subgroup here is 5. So that's different there. So okay, 3. So keep adding 3. So 3 plus 3 is 6. Plus 3 is 9. And then we add 3 again and we get 12, which is going to give us 2. Then leads us to 5 and 8. Add 3 again to 8, we get 1, 4 and 7. And then add 7 to 3, we get 0. Just about fit it in there. So then that also equals the whole group. So this is also of order 10. Okay, let's try 4. Let's leave a bit more space, I think. 4, keep adding 4. So 4 gives us 8. 8 plus 4 is 12, which gives us 2, which gives us 6. 6 plus 4 is 10, which then sends us to 0. Okay, so this group here is of order 5. So the element 4 is of order 5. Let's look at 5. So keep on adding 5, modulus 5. Modulus 10, I should say. 5 plus 5 is 10, which is 0. And then 0, we know when we add 5, we get back to the original element. So this one is of order 2. Okay, let's try 6. So start with 6. Keep adding 6 modulus 10. So 6 plus 6 is 12, which is 2, gives to 8. 8 plus 6 is 14, sends us to 4. And then 4 plus 6 is 10, that sends us to 0. So 0 plus 6 will send us back to 6, as we know. So this one is of order 5. Okay, let's try 7. So keep on adding 7 modulus 10. So that gives us 4, that gives us 1, gives us 8, gives us 5, gives us 2, gives us 9, gives us 6, gives us 3, and then 0. So 7 generates the whole group. So 7 is a generator, so it's of order 10. Just write this 5 a little bit better. Okay, let's try 8. So 8, keep on adding 8. So 8 goes to 6, goes to 4, goes to 2, and then goes to 0. So that's of order 5. And then finally, let's just write down on here, number 9, the last one. So 9, adding on 9 modulus 10 gives us 8, 7, 6, 5, 4, 3, 2, 1, and finally 0. So we know that this is also a generator. So this one here is of order 10. Right, now let's have a look, see if there's any relationship between all these. Okay, interesting to see here is 7 is a prime number. Now, one of the rules in group theory when we're doing addition modulus the prime number with all the elements from 0 up to that prime number minus 1 every element is a generator of the group. So if we say the element order of the group, which is n, so n, and we divide it by the highest common factor of the group, so the highest common factor of 7 between all of these and the element itself. So the highest common factor between, for example, 4 and 7, that is 1. So again, let's pick another one. Highest common factor between 2 and 7, that is also 1, obviously because 7 is a prime number. Now if we take the order of the group, so let's say order of the group, and divide it by the highest common factor of the element. So for example, we'll just call that A, as we did here. So the highest common factor of A and N, which is N is the order of the group, I will say this equals the order of the element. Okay, let's give this a try. Let's see what happens. So let's give it a couple of goes. So let's take the first group we did. So for example, let's have a look at between 2. So let's pick element 2. So the highest common factor of 2 by the order of the group, which is 6. So their highest common factor is 2. So order of the group is 6. So that leads us to 6 divided by 2, which gives us 3. That's the order of the element. So that shows there. Let's pick another one. Let's pick, for example, 4. Actually, that's also 3 as well. Let's pick another one. Let's just pick 5. So highest common factor between 5 and 6. 6 is the order of the group. Highest common factor between these, because they are co-prime, is 1. So then we get 6 divided by 1, 6 order of the group, divided by 1, which is the highest common factor, following this formula here. That also gives us 6. So 5 is of order 6. So it works for this group. Now here, every element in here is co-prime to the 7. So it will give us a similar result to this. So for example, highest common factor of, let's pick 2 and 7. 7 is the order of the group, is 1, which leads us to 7 over 1, which equals 7. Element 2 is of order 7. Okay, let's try a few in this one here. Let's see what result we get there. Okay, so let's pick number 2. Highest common factor between A, so element 2, and N, which is the order of the group, or the order of this group is 10. So highest common factor between 2 and 10 is 2. So now what we're going to do is order of the group, 10 divided by the highest common factor gives us 5. 2 is of order 5. Let's try 5. Highest common factor between 5 and 10. Again, A is the element, N is the order of the group. This is 5. Obviously, highest common factor between 5 and 10. So now we've got 10, order of the group, divided by 5. That gives us 2. So that works. 8. So highest common factor between 8 and 10. Their highest common factor is 2. 2 goes into both of those. So then that leads us to 10 over 2, which equals 5. And 8 is of order 5. Okay, so the only way, value for the element that this doesn't work out for is 0. Obviously, highest common factor of 0 and 10 is a little bit, it's just crazy, it doesn't work properly. And then also when we come to divide something by 0, we can't do that either. But there we go. So I'm going to leave you with this. If we take order of the group divided by the highest common factor of the element A and N of the order of the group, that gives us the order of that particular element.